So here to sum up are a few of the key ideas that you've seen so far and a few new ones. So there are two types of charge on the atom. This you're fairly familiar with, negative and positive. When there is a surplus of charges, then the objects are either positive or negatively charged. Like charges repel and opposites attract. Now it's important to make the distinction between situations where you have static charge, the accumulation of charges that cause positive and negative, and when you have something called a flow of current. The effects that we're talking about at the moment only happen in insulators. These are materials that have very few free electrons and they cannot easily flow. So plastic, glass and wood. So when we talk about static electricity, we're talking about the effects on insulators. But when we're talking about the flow of electrons in a circuit, we're only dealing with conductors. And the most common conductor is a metal. Semiconductors are a bit of an exception, but we'll deal with them in a different chapter. Now we need to talk about charge in some numerical fashion, so we can start looking at how positively charged something is or how negatively charged something is. In order to do that, we need to define the unit, charge, which has a symbol Q, and the unit of charge, which has symbols of coulombs in C. One example would be the electron. The electron is negatively charged and its charge is 1.6 times 10 to the minus 19 coulombs. Charge is a scalar quantity. So although we do refer to plus and minus charges, that's a description of the particle that we're talking about. The actual numerical value is definitely a scalar. Coulomb can be defined, and this is the full definition, which I don't want you to worry about just yet. The full definition is the charge transported by 1 ampere in 1 second. That's the coulomb. Although we haven't spoken about the ampere very much, I don't want you to worry about the definition just yet. But do take a close look at the relationship. To calculate the charge on an object, you would need to look at the current times the time. Current is measured in amps and time is measured in seconds. It's a simple formula to use and we'll have a few examples in the next activity. Now let's have a look at some of the questions about charging objects up. It's very important to remember that in a closed system, the amount of charge in total in the system is always conserved. So when you have two objects interacting with each other, the total charge that they have should stay the same. As you can hear here, we have 5 and we have minus 11. The total charge before touching is minus 6. Whilst in contact, spheres evenly distribute their charge. The 5 and the minus 11 will cancel out, and eventually it would become neutral. However, not exactly neutral, because there is more negative charge. The total charge after touching, after this redistribution of electrons, would have to be the same. It would still be 6. Just to run through the two ways that you can charge an object. One is by friction. That's when you physically rub an object with like a cloth or something. Polythene charges negatively. Where does it get those negatives from? It literally rips them away from the cloth, accumulating them and developing a net negative charge, leaving the cloth positively charged. Charging by induction, however, is different. You don't need contact. Here we have a negatively charged rod repelling free electrons and pushing them away. So here you can see, because of the repulsion, the electrons that were here have moved to the other end. Now, you have to get rid of those extra electrons, so if you earth it, in this case, the electrons fly down the wire, leaving a net positive charge. Once you remove this initial negatively charged rod, you're leaving a totally charged sphere.